This one I wrote in two ways because, of course, if -1 is the lowest x can have and it goes up to infinity, then x always has to be greater than -1. You all need to be aware that that and that are the same things. It just depends on who has written the textbook or the test that you are writing. Okay? This one is the one most math guys like to use because it's shorter. Be aware that they are the same thing. Now, on this one, what if you decide that that curve isn't flat and is very slightly going up still? Then what happens to this y? It's going to be what? Infinity, right? So it just depends on how you read that line. If you read it as a curve that is continuing to go up slightly, it will be infinity. If you read it as flattening out, like we read number 3 as, then you stop at 3. Just depends on how you read it. Aiden.
If you read it as curving downwards, could you write the second one as green instead of -3, infinity?
So you're saying you're envisioning this going down?
I didn't personally, but I'm wondering if someone else might.
Yeah, you could have. If that's going to be the case, then it would be +3 down to -infinity. But in 20 years of giving this question, I've never had anybody envision it going downwards. But it is possible. Yes, I understand. And there will be some that do that. So I'm glad you asked. Any questions from the first page? Please notice, because they were all lines, we could do set notation or interval notation. Is everyone okay with all of these? Page over. Notice this one is not lines. So you cannot use greater than, less thans, or interval notation. The domain is -5, -4, -1, 1, 4, and 7. And then the range are just all the y values. -5, -1, 2, 3, and 5. Now, a mistake that my students often make, because I spend so much time talking about ordered pairs, right? X comma y, and that this point right here, for example, is -5, 5, right? You're all very good at this because you did a lot of this in grade 9. And most of you are figuring out domain and range. These are the x's and these are the y's. But the mistake that a lot of you will make is, because this first x is here and this first domain value is here and first range value is here, you will make the mistake of thinking that -5, -5 is one of the pairs from the graph. And it is not, is it? Because -5, -5 would be way out here. And there is no dot there, correct? Once you have put them into domains and ranges, you can no longer line them up as ordered pairs. Does everybody understand that? These are just x values. Okay? Pardon me? That happens to work out here, you're right, but it won't always, because sometimes if I had a bunch, you'll notice we only have 5 range values but 6 x values. So you understand? So don't get trapped. What I'm saying is don't get trapped into trying to find a pattern like that when it isn't really there, when it's just luck that it happened that time. All right, so where was I here? 1, 2, 3, 4, 5. Round bracket, because it doesn't equal 0. Curves always cause kids problem on range, because when we do range, they want to go from point to point. Right? They say, okay, well, it starts right there and it goes up to there. Oops, that's supposed to be red for range. But it doesn't, does it? Because the curve goes all the way up to there, because I'm not looking at the curve anymore. I'm looking at just the domain values and just the range values. So this one is actually -1 y, and it goes up to 1, 2, 3, 4. Now, somebody always says with this question, but Mr. Myers, you said that's an open dot. And right in my range, you say it goes from -1 all the way to 4. But it doesn't include that dot. And that dot is between -1 and 4, doesn't it? Isn't it? But it does include that because over there it hits -1. Does everybody understand? So even though this point doesn't exist, that range value of 1 does. Everybody cool? Okay. This one, since there's an arrow there, if you didn't see that as an arrow, you're going to have a different answer than me. But for this one, you could have -infinity less than x less than or equal to 1, 2, 3, 4, 5, 6. Or you could have x is less than or equal to 6, because that takes us all the way down to -infinity anyway. Or round bracket, -infinity, 6 square bracket. Range is tricky. The range is -2 less than or equal to y less than or equal to 1. That covers this part of the range. But there's another range value of 1, 2, 3, 4. So I got to have a union with y equals 4. Okay? This one, no problem, -2, 1, union 4. Okay? Oh, and just quickly, is this one a function? No, because a line hits 2 solid dots. This one, arrow there, arrow there. So is it going to go all the way forever on the x's? That way? Yep. Is it going to go all the way forever on the x's that way? Yep. So this, we write this weirdly. And ladies and gentlemen, I do not really care about this. When you're doing proper set theory, if you go further in math, there's all kinds of weird ways to write it. And when you look in the textbook, you're going to see some of those weird ways. I don't care. Okay? So this, they would say x, and they would probably put a colon, x, colon, because we're talking about the x's. Then they would say x, and then they would put this big funky e, and then an r, which says x is all the real numbers, because it goes from -infinity to +infinity. Does everybody understand? I don't want to fill your head up with this stuff, because you guys get, what's the word I'm looking for? You get hung up on things like this that aren't part of the math. Do you understand what I'm saying? Like when you're trying to put your polynomials in the proper order and stuff. I don't care. So I'm just showing you this because I think it shows up on some of the textbook pages I photocopied for you. Okay? That's all that means. And I forgot to mention it yesterday because I was just trying to get the concepts into your head without this. Okay? So this also could be written, of course, as negative infinity, less than x, less than positive infinity, or negative infinity, comma, infinity with round brackets. All those are the same thing. The range is only negative 3, 0, 3, and 4. And you got to put the squiggly brackets for the range. Negative 1 less than or equal to x less than 1, negative 1, comma, negative 1 with a square bracket, 1 with a round bracket, negative 2 less than or equal to y, 2, 3, 4, 6, 6, square bracket, negative 2, 6, round bracket. Oh, it's negative 3, thank you. Old eyes. And this one, a lot of people have trouble with this one, but just because it looks different, right? But if I didn't have any of this part of it, your domain is just here to here, isn't it? So it's the same. My domain is still 1, 2, 3, 4, negative 5, 5. And my range, same thing. It just goes from there down to there. Doesn't matter what the curve's doing. Anywhere there's a y value is a range. And that's 5 to 5 again. Oops. Did 2 negative 5s there. Everybody cool? Now, I didn't go over. Is there anything on 148? Everyone was good on 147, at least you all told me you were. So 148, I didn't talk a lot about yesterday. It's the exact same as 147, but they're on the graph instead of being written out. Does anybody want to ask about anything on 148? You did have the answers there, and everybody seemed really good with 147, so I didn't spend a lot of time on 148. Are we okay? Everyone, if you attempted it? Yeah? All right. Let us go on then to the next lesson. Okay, this is when your Science 10 is going to come in if you have done Science 10. This lesson is not so much a lesson as it is reading graphs and hitting a couple of technical things that mess people up. So let's start with this first one here. You already know how to do all of number 1. So try and fill that in with the people in your general area or by yourself. It's fine. Go ahead and try to do all of number 1. Make sure you leave a little bit of white space, like put your answers over on the far left, so in case I got to fill in something else, there's room for me. So write your answers kind of down here, and then we'll put any points I have to make in here. Okay? Go. Everything I said about this, you have to remember it. Or just watch the second class again. In block D, I got a kid that sits right there. And he says every time, are you recording? 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 Step up, Wong. Come on. No stress, buddy. So I never forget to record. All right. So What is happening from A to B? What I shouldn't say that. What is something that could be happening from A to B? Evan. She fills up the watering can. Was the watering can empty? No. There was a liter of water in it. Right? So, what's happening to get the C? Fills can. That tells me you understand the can is filling up. Great. That's a 1 or a 2. Everybody cool? How could we make that better? Fills can. Finishes filling the can. Something like that to show me that you know it had some water in it already. Could you go one step further? You could tell me how fast she fills the can, couldn't you? How fast did she fill the can? How much water went in? It went from 1 up to what? 1.75. In how long? 30 seconds. So she fills can at a rate of 0.75 liters per 30 seconds. Now that's a stupid, what you're about to say is what I'm getting to. We would never measure time, a speed that way, would we? Would we? Do we on the highway say the speed limit is 40 kilometers per half hour? No, what do? We try to get the time into single units, right? So what would be a good single unit here? Do we want to have seconds or per minute? Per minute. So this would have to multiply by what? 2. So what would this have to multiply by? 2 to get 1.5 liters per minute. Everybody understand? That would work too, but usually we like our speeds to be in unit rates. Okay? Everybody cool? That would get you the full gold star, Myers cartwheeling down the hallway. Yay. Everybody understand? Filling the can, true. Right? Okay, that's point 1. What happens in stage 2? What is something that could be happening from B to C? Pardon me? She walks over to turn the water off, so the water is still running here. So at B, she turned off the water. Okay. Then what happens from B to C? She walks to the plants. If she's a nice person. If she isn't a nice person, maybe she's walking over to her little brother to pour water on him or something like that. So, B to C, she stops the water at B, and Evan, who's a good brother, she's just walking to the garden. Right? Now, if you're a bad brother, your sister's lying in the sun, minding her own business, has sunglasses on, and you walk over and you dump the water on her. But I don't think, Evan, you would ever do that. I would never do that. My little brother did that to my sister all the time. You would think she would have figured it out, but she didn't. She would continue to sunbathe in the backyard. And my brother would continue to dump freezing cold water from the hose on her all the time. And then she would get mad. I'd be like, Lee, this is at least partly your fault. Anyways. And what happens at C? She waters the plants. That gets you, that'll get you that will get you some marks. How can we get more marks? You describe more information to me. Does she empty the watering can? Yes. Waters the plants. Empties the can. Faster or slower than it filled? faster. How do you know it's faster? The line is steeper. In a very little amount of time, she got rid of all the water. Right? How could we figure out the actual rate? It's always time. I shouldn't do that. Sorry. It's always dependent variable divided by independent variable. Or range divided by domain. So how much range was lost here? 1.75, correct? Because she went from 1.75 down to 0. So 1.75. That's going to be a big mess because I wrote it like 4 times. As soon as it shows up. If it shows up. Maybe it'll show up. I don't know. There it is. 1.75 over what? How long did it take? 10, 20, right? Is that correct? Yeah, that's what happened. Is that the way we would like to write it?
No.
What's wrong with that? We don't like the 20 seconds. What would be a better time there? A minute. So what do I do to get 20 seconds up to 1 minute? 1 minute is how many seconds? 60. So what do I got to do here? Times 3 to get 1 minute. So what do I got to do up top? Times 3, which is 5.25, right? Yeah. So she empties it at 5.25 liters per minute. Does everybody get it? Can you work both ways? You can get the numbers from, or the story from the graph, and you can write the story that goes with the graph. Is everybody good? Okay. Now, you're going to try this. Okay? Now listen to me, please. I do not want to scare you, but when you attempt this on your own, you're going to make a mistake. Do me a favor. If you don't have a pencil, no, do it, but try to cram it in on half the graph so you can do the proper one over here. If you have a pencil, you can use the whole amount of space. Okay? Work with your neighbor, try it out, see if you can figure it out. Don't worry if you get to a spot where you're stuck. Just stop your graph there. Okay? Everybody good? All right. Wong, I am pausing the recording. Wong! Why is time on the x-axis? Because it's the independent variable. Exactly. We're not driving to Grandma's house, but time is still passing for us. Excellent. So I need to cover the first 2 hours. So there's 2. Time is in hours. What's on the y-axis? We're measuring it in kilometers, but what are we measuring? Distance. Excellent. Distance. And that's measured in kms, right? So I'm going to go up by 10, if that's okay. So there's 50. Everybody cool? All right. So the first 2 hours, Jack leaves home and travels 140 kilometers at a constant rate. Okay? So what does that mean? What does that mean? He's going out 2 hours, and how far up does he have to go? $100, 150. So up to 150 and 2 hours. Does everyone agree? Or 140, right? And since it's constant, we draw a nice straight line. Now we know that's impossible, isn't it? Because he doesn't live on the highway. To get to the highway, he had stop signs and all that stuff. But for our purposes, we're happy with this, yes? Everybody cool? Then what happens? Visits his grandma for 1 hour. Is he traveling any distance while he visits his grandma? No. Is time carrying on? Yeah. So what kind of line must I draw? Straight. Flat. For how long? 1 hour. 1 hour. 3. So this is A. This is B. Now here is where you're going to make your mistake. How many of you made the line go back towards home? Be honest. Or how many of you didn't get here yet? Okay. If you were going to draw it, would you draw going back towards home? How many of you would? Be honest. Most of you. Usually when I get this question to be done, everybody in the class says he's driving back home. That's not right, is it? Because I wanted a distance time graph. While he is driving towards home, is he still covering distance? Yeah. Is the odometer on his car still going up? Yeah. Not like in Ferris Bueller where they try to put it in reverse and run it backwards, which doesn't work. So for a distance graph, it has to keep going upwards because he's still passing distance. Does everybody understand? So the way I've drawn this is impossible, isn't it? Because the way I've drawn, I'm going to go off the graph. So I would have needed to change this scale. Does everybody understand? Okay. So now that you know what you know, I'm going to erase this and I'm going to change this side to 25s. There's 100. There's 200. Right? So in 2 hours, 140, 25, 50, right there. There's A. B for 1 hour. There's B. Now, what happens at 3? He drives 50 kilometers towards home, but then stops 30 minutes for supper. Does it give us anything about how fast he drives this? So we can choose that, can't we? The only thing we have to cover is we have to go from 140 up to 190 in some amount of time. What would be an appropriate amount of time, do you think? I just spent like 5 minutes explaining that. Perhaps you should have listened. I'll explain it again in a second. Okay? So, what would be an appropriate amount of time to cover 50 kilometers? We know that he drove 140 kilometers in 2 hours. It means he drove about 70 kilometers an hour, yes? Well, he only drove 50. Excellent, 40 minutes. So not quite a full hour, right? So I go up to 190 in not quite a full hour. That's C. Then what happens for half an hour? Stops to eat. So what kind of line do I have to draw? Y. Time goes on, distance doesn't. So now here I am up at about 4.5 hours, yes? And then what? This is all C. Then he drives home, but he takes 2 hours. He took 2 hours to get to Grandma's, but he's taken all this time, and now he's taken 2 hours to get all the way home. Will the line be steeper or shallower than here? Will it be steeper or less steep? Is he going the same amount of time? 2 hours to get to grandma's, now he's taking 2 hours to get home. Is it the same amount of time? Yes. Is it the same distance? No, because he's already covered 50K, hasn't he? So this line will be steeper, the same, or less steep? Less steep. Same amount of time, but less distance. Does everyone understand? So D will take us out to, we're at about 4.5. It'll take us out to about 6.5, and it'll be less steep than here. There's D. Is everybody cool? Now I'm going to come back to what Michael asked, and I'm going to explain it again. The question asked for distance traveled. Does everybody understand? Okay. Here I am. I'm going to travel some distance. Everybody ready? How far did I travel? 2 steps. Everybody cool? 2 steps. Yeah? Now how far have I traveled? 4 steps. How far have I moved from where I started? 0. Distance. How far I actually moved. Displacement. How far I moved from where I started. Everybody cool? You should have heard these terms in science class. All right? This is distance. So it must increase. Distance is scalar, which means it is a measure of magnitude. You keep counting. It keeps going up, like the odometer in your car. No matter where you drive, that odometer keeps going up. Even if you just drive up and down your driveway 100,000 times. Everybody with me? Scalar means it is a magnitude, which is just a total. All right? Displacement is a vector, which means it has a magnitude, which is size, and a direction. Learn to write, you idiot. Does everybody understand the difference? Now, in the real world, there is an infinite number of directions, yes? We can describe an infinite way of moving about, can't we? In math, what can we have? What are your only options in a math class? Pardon me, say it loud. Plus and minus, there's only 2. So to make a graph work for real life, we've made some rules. And the rules are as follows. Positive numbers are up, right, north, east, and things like that. Everybody cool? Negative numbers are the opposite. Down, left, south, west. Oh, what about this one? Forward, backward. All right? So, let me make sure you guys all have this. Where is your left hand? Your left hand is over here, correct? So that would be negative, yes? So how far have I traveled distance? No. Distance. How far did I travel? 3 steps. How far did I displace myself? -3. Because it's 3 to the left. Is everybody cool?
Yes.
Now, I am now going to displace myself 3 steps again. I'm going to displace myself 3 negative steps. Where will I end up? By the door. What's my distance? No. 6. Distance has no direction. I have traveled 6 steps. What is my displacement? -6. Now, 1, 2, 3, 4, 5, 6. 6 positive steps. What is my distance traveled? 12. What is my displacement? 0. Because I went 6 negatives, then 6 positives. Do you understand? Aiden.
So basically, it's impossible to have negative distance because you're always going up distance.
Yes. Distance is always going up because it's scalar. Everybody understand? Now, what if I change this graph, and I'm going to draw this line in green, to a displacement graph? What happens right here when he starts going back home? It just flips down. It would go down a little, then flat, then home. Everybody understand? I can tell by how many people are talking to each other that they get it. So, look at number 4. It is slightly different. Look at it carefully when you try to describe this to me. Go. It's not a distance time graph, is it? What is it? Speed and time graph, right? So, what happens at 0 time from 0 time to 2 seconds? She's increasing her speed, which we call what? Acceleration. Right? Okay? So, for the first 2 seconds, from 0 to 2 seconds, she accelerates to what? To top speed of what? Top speed of 8 meters per second. Right? Then what happens from 2 to 14? She maintains. Now, why is Michael saying velocity and some other people are saying speed? Does anybody know? Velocity is the vector. Velocity as a direction. Speed is scalar. It doesn't. So if I'm running down the road or driving down the road, I'm going 80 kilometers an hour. That's a speed. If I'm driving away from my home, that is a velocity, and it would be positive 80. If I turn around and drive home at 80 kilometers an hour, I'm still going 80 kilometers an hour of speed, but in a velocity, I'm going negative 80 because I'm going back home. Everybody with me? All right. So she maintains 8 meters per second. And what happens from 14 to 16? What happened at 14 seconds? Why? What happened? She crossed the finish line. If she crossed the finish line and stops, why doesn't this go straight down? Because she has to slow down. The only way it could go straight down is if she ran into what? A wall. go down pretty fast. Everybody understand? She crosses the line and slows down. Everybody good? Excellent. Let's moving along. Number 5. Go. You did do it wrong. All right. What's going where? There's my graph. Height. Time. Everybody should have at least gotten that far, yes?
Oh, I got drawing.
Okay, now, at 0 time, where does your line have to start over here? At the bottom? Kind of hard to swing if the swing's sitting on the ground.
Oh, it's because they're like, oh.
So can I have my height at 0? No. It's got to be a little bit off the ground, technically, yes? Yeah. Everybody cool? All right, now, what happens? How do you start a swing? You stand up, right? And you lift your feet off the ground. So the height of the swing went up how much? No, I sat and it's at 0. Here I am sitting on the swing. Okay, now how do I make it go? Well, if I'm a North American kid, even if I'm 12, somebody push me. But in the rest of the world, when you're 4, how do you make a swing go? You stand up. What's happening to the swing? It's up. How much? Very little bit, especially with me, because I've got very short, stumpy legs. So I go up a very little bit, yes? Then what happens? I lift my legs and I go down, right? Can I go down below this line? No, because that's the lowest the swing goes. Right? Now, if I actually know how to swing, my next swing will go where? Slightly higher. In the same amount of time? Or am I speeding up as well? Speeding up. So my height goes up to a little higher, and it's a little bit steeper. Then what happens?
Okay, go down.
I go back down to what?
To the same line.
To the same line. Then I go a little higher, faster or slower? A little bit faster. So steeper or less steep? A little steeper. Then what? Back down to 0. Then what? A little steeper, a little higher. Back down. Now, this is what will actually happen. Somebody always draws the swing this way. Because you're swinging. Always. Always. What is wrong with that? You're swinging faster than the speed of light because you're going back in time. Okay? That's like in grade, when you first get on the swing in kindergarten and some big grade 6 kid comes along and says, one time I swung so high I went all the way around. And you're in kindergarten, you're like, no. And the grade 6 is like, yeah. So when you're in kindergarten, a grade 6 looks like a man. Yeah. And you're like, I'm going to try. And then you can't because it's impossible. But it is impossible. No. Off the swing, yes. You cannot make the swing go around like the beast at Playland. And you cannot make time go backwards, no matter how fast you think you're going. I'm going so fast at the swing. I'm going the speed of light. No, you're not. Everybody good? All right. Try the next one. Look at the definition. Look at the definition. Try to draw the graph. Go. Yeah. It is impossible. It's on the internet. It's true.
watch the video.
Oh, wait, yeah, you're right. I've seen a video of aliens busting out of people's tummies on the internet. Is it real?
That's Alien versus Predators.
It's actually Alien, the first one. Or Spaceballs, where the alien comes out and down. I love how you guys think that he could stay on there when he stopped like that with one hand. I'm pretty sure it's real. We're pretty sure it's real. All right. What goes on the x-axis? Time. What goes on the y-axis? Distance. It's on a track. Yeah, of course. Somebody always graphs this way. He ran around the track. He ran so fast he ran back in time. He's the Flash. He's in the Speed Force. Look out. What is the top of the distance scale going to be? 400. This you probably measure in minutes. 1, 2. If you're not very fit, 2 minutes to run 400 meters. That's what it would look like. Why does it continue to go upwards? Because you are traveling 400 meters of distance. It doesn't matter what direction. Everybody get it? Everybody understands why it's not an oval? Okay. Aiden. Yeah, technically it should be slightly curvy. But I'm going for concept here. What's different about number 7? Displacement. What happens a quarter of the way around the track? No. No. What goes down here? Time. What goes over here? Displacement. Which means I have to care about distance from home, yes? What does a track look like? It's an oval, yeah? So if I start right here, I'm going to run 100 meters, aren't I? Straight away, right? So since it's displacement and I'm going away from my start, is it positive or negative? Positive. For 100 meters, yes? All right. So for the first 100 meters, which let's say takes what? 20 seconds? If you're sprinting 100, you're doing a full 400. So can we say 20? All right. So 20 seconds, 100 meters, and Aiden's right, there should be a curve, but, right? Now, what happens here? I'm turning. So am I going as far away from start? No, I'm actually going less distance away from start, aren't I? But I'm still going away from my start, aren't I? Yeah. So is this line going to get steeper, shallower, or stay flat? It can't stay flat, can it? Because I'm moving. So, if it's getting steeper, that means I'm getting further away from my start in less time. Am I? I'm getting further away from my start in less time? Because now I'm going this 100 meters, yes? I'm no longer going in a straight line, am I? So I have to curve, don't I? No. Yeah. Am I still going away from my start? Am I still going away from my start? Yes. So I'm still going upwards, but it's not straight away from my start. So it's got to be less steep. I should have drawn the first one steeper. Less steep. Now what happens here? I'm now as far away from home as I can be.
That's good.
But what is happening now? Aren't I going back towards start? But I'm still away from it, aren't I? So I still have to go upwards, don't I? Because I'm still getting away. But am I? Isn't this distance... Isn't this distance less than this distance? So on a displacement, aren't I getting closer? So I got to come back down, don't I? Because I'm getting closer, yes? And what is happening as I come around this corner? I'm still getting closer, aren't I? And I'm going to end up back home. Does everybody understand the difference? Michael.
Can you just draw a triangle? Not like on the graph, because you're going away from it and then you're coming back to it.
That's the point I'm trying to make. If it were a circle, we could draw that, because a circle is always the same distance, yes? But because it's an oval, right, we have to have, it's got to be layered, right? Do you understand what I'm saying? Why it's different?
Yeah, I just automatically assume that there's no circle.
Yeah.
Technically, it is a racetrack, so you can make it whatever shape you want in your head.
That's what I'm just saying. If you were to say, if I told you to do this, and you said, I'm running in Bangladesh where the tracks are perfect circles, then you could, that's fine. That shows me you know what you're doing. Listen, please, you have one question of homework, which means, of course, 80% of you won't do it. Do number 8. Please notice I have said it is a position time graph. Okay? Is position displacement or distance? Don't say it out loud. That's what you got to figure out. Is it displacement or distance? I'm not saying anything. Because I want you to see if you can figure out. Huh? I know, but I'm not giving away the answer. Elijah. It isn't displacement, but it is distance.
Okay. Thank you, John. It's okay.
I gave you no answer there. That was the point.